additional of external device to control system. Doing that, why we are doing this, or redesigning or adding an additional circuit to the control system, is because we want a system, we want to improve the operations of the system in terms of stability, in terms of accuracy, in terms of the accuracy, in terms of the speed of response. The speed of response. We want a system we can respond quickly. So these three requirements is forced us to redesign the circuit, and redesigning the circuit, then we are calling it compensations. Now in this lesson we want to look at the types of the control system. So types of the control systems, types of compensations, you mean. So one, we have what we call the phase lead network. Number two, we have phase lag network. And three, we have phase lead lag network. So we've got three types of compensations, and now we want to start by looking at the phase lead network. The phase lead network, the uniqueness of the phase lead network is that it has poles. It has poles and zeros. And we were saying last time, zeros makes the system to be accurate. Though having poles to be dominating means the system could be unstable, the system could be slow to respond, but but the system finally will be accurate. The system will be accurate when we have the poles. Now, again, it has the zeros, and we say when the system has zeros, then it means the system is stable and the system is quick to respond. So phase lead network has got poles and zeros, but the zeros appears at the origins. Zeros appears at the origins. Now, having zero appearing at the origins becomes, so in phase lead network, zero is dominating. So zero is dominating. We shall look at that after deriving it. So let's see a circuit that have that. So this one, we have this as the circuit. Then this one is going to be the capacitor. We have here the resistor. And then we have in parallel with another resistor. So we have this as V out, V out, and this one V in. So this one is Z, this one is R1, this one is R2. You can be asked to determine the transfer functions, df, and transfer function is given by this equation, V out all over V in, the ratio of that. So we want to do So we want to look at the transfer functions. Transfer functions of facelifts network. We want to look at the transfer functions of that system. So how do we do it? So the facelifts this way. This is R1, this is capacitor, this is R2. Transfer function is given by this V out over V in. So from our system here, V in is equals to I current going through that circuit, the total current, into the equivalent of this is going to be portable over the side, which is going to be R1 all over SC into R1 plus 1 over SC plus R2. That will give us the V out. Further simplifications, we're going to get that one is going to be R1 all over SCR1 plus 1 plus R2. Now this is to represent V in. V in is going to be equals to R1 plus R2 into SCR1 plus 1 all over SCR1 plus 1. Then you come to V out. V out is equal to the current. The V out is equal to the voltage across the resistor connected in parallel. So it is going to be R2. So V out all over V in is going to be equals to R2. I and I will cancel. We shall remain with R1 plus R2 into SC R1 plus 1. Here multiplied by this SC R1 plus 1. So this is what we're going to get. We're going to let alpha be equals to R2 all over R1 plus R2, and the time constant T is equals to CR1 So we need to modify this equation. Then we are going to get R2 all over R1 plus R2 SCR1 plus 1 . So by opening this bracket, then we are going to get here R2. So this and that give us 1 plus SCR1 R2 all over R1 plus R2. So you substitute from here this. So this one is going to be alpha, and then R1 is the theta. We are going to get into ST plus 1 all over 1 plus SCR. That one is the time. So we are going to get ST, and then the whole of this, which is this, is the alpha. And that is how we can derive the transfer function of a facelet. Now when we reach here, then we need to plot this on the S plane. So plot this equation on the S plane. So how do we achieve that? We're going to say ST plus 1 is equal to 0, and then this one 1 plus ST alpha is equal to 0. So this one is going to give us the 0, and this one is the ball. So by putting the 0, we are going to get, so find S, because we want to plot the S plane. Then we are going to say ST plus 1 equals to 0. So ST is going to be negative 1. So S is going to be 1 over T. Then you go to the other one. So this one is going to be the 0. And then you go to the other one. ST alpha is going to be negative 1. So S is going to be negative 1 all over T all over alpha T all over alpha T. So you draw the S plane. Since it is on the negative sides, then this is closer to the origin, this one. So zeros is represented with a circle. So this one is represented by a circle, and then this one balls is represented by a star. So this is our 0 point, which is represented by -1/t, and then this one is going to be the ball, -1/1/t. So from this extent, you can realize that the phase leads network, the 0 is close to the origin. So if it is close to the origin, then you say the 0, you call it 0 dominating. So 0 dominating. So 0 dominating in the phase leads. So in this system, 0 dominating, it means that the system is stable. The system is stable, and again